This is Unit 11, Lesson 7, Writing Sigma Notation Formulas. And in this section, we're going to kind of go backwards. They're going to give us a series. In this example, they've given us the series 11 plus 14 plus 17 plus ... plus 95. So we know that our first term, a sub 1, is 11. We know that our nth term, a sub n, is 95. We can then find our d value. Now I will say this only works for arithmetic sequences. I can't give you this for geometric. There is a way to do it, but we don't need to do that in Algebra 2. But for sigma notation, we can write arithmetic series notation. I'm going to write my sigma. Whenever I write a sigma notation, I always, on the bottom, start with my first term being n equals 1. My last term, or the number that goes up here, I will find using what they gave me for the nth term. We'll talk about that in just a minute. This right here will be the formula for a sub n of the sequence that we have here. Now this is a series, but you understand that is also a sequence of numbers. It's an arithmetic sequence. How do we know it's arithmetic? Well, we check for d. We add 3 to get to the next term here. We add 3 to get to the next term here. So we know it's arithmetic because we're adding 3 each time. Our d value here is 3. So I'm going to use my original formula for an arithmetic series. A sub n equals a sub 1 plus n minus 1 times d. And I can use that formula to find everything that I need. So the next thing I need to do is I need to find the formula for this arithmetic sequence. Well, remember, back a couple sections ago, we learned how to write the formula for an arithmetic sequence. We said that if we let a sub n equal, and then we plug in a sub 1 and d, a sub 1 is 11, d was 3. If we plug all that in and then simplify it, we will have the formula for this sequence. Well, if I do that, a sub n equals 11 plus 3n minus 3. So a sub n is equal to 3n plus 8. This is the formula for my sequence. That's the formula for this sigma notation, 3n plus 8. So I put my formula for the sequence here. Then the only other thing I need to do is I need to determine what n value will give me 95. Well, if I want to figure that out, all I have to do is set this equal to 95, right? This is the last term, so that's what a sub n equals. If I set a sub n equals 95 equal to my formula, 3n plus 8, won't that give me the term number? 95 minus 8 is 87. That gives me 3n. And then if I divide by 3, n is equal to 29. So 95 is the 29th term, or it's what we get when we plug 29 into my nth term formula. So we have now written this series as a sigma notation problem. Here's my second problem. I want to write this series as a sigma notation problem. I start with 8 plus 10 plus 12 ... plus 62. So I'm adding all of the terms from 8 to 62 of this series. Well, we know from what they gave us, a sub 1 is 8. We also know that a sub n from what they gave us is 62. So we know for our sigma, this always starts with n equals 1. We then find the arithmetic sequence formula using our a sub n equals a sub 1 plus n minus 1 times d. That means we have to figure out what d is. Well, what am I adding to get to the next term? And remember, we can only do this for arithmetic sequences. We will not do this for anything but arithmetic. So we're adding 2 to get to the next term each time. So that makes our d value equal to 2. This term is always n equals 1 when we're writing the series. Now we need to find the formula. I'm going to go up here. A sub n equals 8, our first term, plus n minus 1 times d, which is 2. Remember, back when we figured out how to write the formula for a sub n, we said we would not replace anything involving an n. We will not replace a sub n and we will not replace n if we're finding the formula. What we need here is a formula. So if I do this, I've got a sub n equals 8 plus distribute, that's 2n minus 2. So I have a sub n equals 8 minus 2 is 6, so I've got 2n plus 6. That's my formula. That's what goes here, 2n plus 6. Then, to determine the number that goes up here, I set my a sub n equal to my formula. So, a sub n is 62. So 62 equals 2n plus 6. If I subtract 6, that gives me 56 equals 2n. And if I divide by 2, that gives me n is 28. N is 28. That will be my top number in my sigma notation problem. Here they're asking us to write this arithmetic sequence in series notation. So I'm going to write my sigma. I always start with n equals 1, and then I write my formula. I know that 9 is a sub 1. I know that 58 will be my a sub n. My d value is what I add to get to the next term. 9 plus 7 is 16. 16 plus 7 is 23. So my d value is 7. I'm going to go over here to my formula and write my nth term formula. A sub n equals 9 plus n minus 1 times 7. So a sub n equals 9 plus 7n minus 7. So a sub n is equal to 7n plus 2. That's my formula that goes beside my sigma, 7n plus 2. And then to figure out what number goes here, I set my formula equal to my last term. 58 equals 7n plus 2. If I subtract 2, I get 56 equals 7n. So n will equal 8. 8 will be my top number in my sigma notation. Here's another example. Go ahead and pause the video, see if you can get this one on your own, and then I'll share the answer with you in a few minutes. So here's the answer. I knew that since the first term was 10, that was a sub 1. My last term was 250, that's my a sub n. I'm adding 10 to get to the next term each time, so my d is 10. I then plug in to find the formula that goes here, knowing that this is always n equals 1. My formula, when I plug into the a sub n formula, would be a sub n equals 10 plus n minus 1 times 10. When I distribute the 10, I have 10 plus 10n minus 10. 10 minus 10 is 0, so my formula is a sub n equals 10n. 10n then goes here, and then I need to set my a sub n formula equal to my last term. So 250 equals 10n, so n is 25, giving me the top number for my series.